Hello and welcome to another video. In this one, I'm going to be going over how I set up Python projects. I'm going to do both a single file library, a multi-file library, and an application, and talk about all the tools that I use and how I configure them. This is just how I do things. You may do things differently. I'm basically just explaining what I do. Anyway, let's jump into it. Okay, so I have cloned 3 different projects that we're going to be taking a look at today, and I'm actually going to take notes at the same time because we're going to be covering a lot of different tools and a lot of different files at kind of the same time. I'm going to start with this one here. This is going to be our multi-file. Let's actually do this notes.md so we get nice highlighting. This is going to be our multi-file library. So we're going to cd into there and look at all of the files that we have. We're going to start at the top level. We probably won't really talk too much about the insides of these directories, but I'm going to talk about each of these files separately. Now, the first one that I actually want to start with is precommitconfig.yaml. Precommit is a tool that I wrote that is a framework for managing multi-language precommit hooks, but also linters, code formatters, and any sort of development tool that you would want to run. And so that's kind of the main entry point for my developer tool set is in this precommit configuration. And so let's take a look at that first. So first we're going to say precommit manages linters, code formatters, etc. It's going to go off the screen. We'll just say that. And so that is in precommitconfig.yaml. And you'll see that I have a bunch of different tools configured here. The first set of tools come from this repository called precommit hooks, which is actually the one that we're looking at today. Yeah, it's a little circular and meta, but precommit hooks has a few out-of-the-box tools that are useful for precommit. Precommit hooks, out of the box, language agnostic. For the most part, where I'm slowly trying to phase the Python specific stuff out of this repo into another place. So you'll see, like, for instance, this is Python specific, as are these two. Actually, all 4 of these are Python specific, but eventually I want to move those out to a separate repository. Language agnostic tools. And I do a couple of things here. Some of them are checking like particular data formats. Others are making sure I don't check in large files. Some of them are fixing white space. This is actually a Python code formatter to enforce single quotes. I know there is a very popular tool which does double quotes, but I prefer single quotes. So that's what some of those do. The next big tool that we run into here is Flake8, and Flake8 is a Python linter framework. It combines a bunch of popular Python linting tools such as PyFlakes and PyCodeStyle and McCabe, and it also provides a plugin substrate, so you can install a bunch of other plugins as well. And actually, I maintain this tool. Admittedly, I maintain this tool as well, and this is a plugin that I wrote for Flake8 that helps manage typing imports. So the typing module has changed a lot between versions, and so I wrote a plugin to make sure that you don't make simple mistakes there. But that's Flake8. I also use AutoPep8 as a code formatter. And this is basically a less intrusive code formatter. So there's a few others that are popular, such as Black or YAPF. I find YAPF to be really, really, really slow. I also find Black to be a little bit overbearing in some of the changes that it makes, so I don't personally prefer it. But again, to each their own. This is my project, so I'm showing you what I do. The next tool that we'll talk about is Reorder Python Imports. This is an import sorter, and one that I wrote. Reorder Python Imports, import sorter. And you'll notice that I've configured it in Python 3.7 plus mode. That's the minimum version that I target for this library at the moment. And I'm also adding from future import annotations to every single file, just to make sure that I always have this import, and this makes type annotations automatically become forward annotations, basically stringifying them so they don't have runtime overhead. I also wrote a tool called PyUpgrade. That is another code formatter. And what PyUpgrade tends to do is it makes code more futuristic. I guess that's one way to put it. So you basically specify a minimum version here, and it will automatically do a bunch of transformations that make your code better. For instance, like using f-strings or using the new, I don't know, what's a good example? LRU cache has changed over the versions, and so it'll use the newest version possible, things like that. There's many things that PyUpgrade will rewrite for you. I guess I can go here and get some ideas. Yeah, like set literals, set comprehensions, you know, all of these sorts of things. It has lots and lots of features here. Yeah, that's PyUpgrade. Next is add trailing comma. This is actually very similar in idea to Black, in that adding trailing commas to calls, literals, etc. Will make them more maintainable, minimal diffs, that sort of thing. And so this is another code formatter. And I actually wrote this years before Black existed, and Black has a lot of the same ideas. But this is not as intrusive as Black. Like, it's never going to reflow your code. It's only going to be, you know, inserting commas and making sure that things are lined up nicely. Next is setup CFG format. This is another tool that I wrote, setup CFG format, and it is a formatter for setup.cfg. And setup.cfg, which we'll get to in a bit, is declarative metadata. It's a way to specify your library metadata in a data file rather than an executable Python code. And I actually did a video on setup.cfg and declarative metadata, so I will try and remember to link that in the description. So this is another code formatter. Oops, another code formatter. But specifically for setup.cfg declarative metadata. Declarative metadata. And the last tool that we're going to talk about here is MyPy. And MyPy is a type checker, and it helps me validate that the type annotations in my source code are correct. That's that. Okay, and these are all the tools that I run as part of my commit lifecycle, and I also run them in CI. Okay, so that's precommit config.yaml. You also notice there's a precommit hooks.yaml. I won't really go into details here. This isn't in most of my projects. This is a piece of metadata that tells precommit how to install the tools. So that's how I was able to, you know, install Flake8, for instance. Flake8 has a file that looks like this, but it's not super important to this repository. All right, next let's talk about gitignore. This is a quick file to get out of the way. This sets up the default ignore patterns for my project. I usually like to sort this. And this is actually one of my older projects, so it has stuff that I no longer use. Like, I don't use Vim, so usually I don't have this. I also don't use my makefile approach, so I could probably clean that up as well. PyTest has put a gitignore file in their PyTest cache, so I can probably get rid of that. Does MyPy do the same? Let's see. Precommit run MyPy all files. MyPy might also do the same. I might be able to clean that one up too. Yeah, MyPy also does that as well. So in theory, I could get rid of. Oops, I didn't save, did I? Anyway, I can get rid of a bunch of stuff in here that I don't actually need. I don't use PyO files either, so I could probably do that as well. And I always want to make sure that this file is sorted. I also don't use this anymore either. Anyway, there's a gitignore file. It basically prevents a bunch of stuff from showing up in git status. This might be a more simplified version of what I would use here. But anyway, let's ignore that for now. Okay, so we have gitignore, prevent untracked garbage, something like that. Let's talk next about, I guess, Azure pipelines. We can do that one next. So Azure pipelines .yaml, this sets up my continuous integration setup, or at least one of the continuous integration tools that I use. And by continuous integration, it's basically going to be my test runner in when I make pull requests and when I merge stuff. And you'll see here that I'm using a template. This is why I use Azure pipelines, for example. This template allows me to automatically configure you know, what operating system and what tox environments I want to target without having to have a bunch of boilerplate. Basically, there's this template job here that expands out into a couple hundred lines of YAML. Utility Azure pipeline templates. See job tox here. So it takes a bunch of parameters and expands out to all of this, you know, 100 lines of YAML here. But this makes it really easy to have reusable CI configuration without having to fiddle around with that. GitHub Actions has a similar feature, but it's not quite there yet. It's missing a few functionalities that I would need. So at the time of recording this video, I'm still using Azure pipelines until that becomes a thing. And I've specifically configured this so it runs on my current primary branch. Sometime this year, I'll be switching master to main, but it's kind of legacy at the moment. I also include this test me star. Sometimes you need to validate your CI configuration, so I find adding this branch that you can push to that will run your CI to be useful. The other thing you could do here is do branches star. The problem with that is every time you make a pull request from inside your repository, your CI system is going to do double work, and one of those runs is going to be useless. So this is why I specifically narrow this down to just running on the primary branch as well as these test branches. It also runs in every tag, and it also runs on pull requests. That isn't listed here. In GitHub Actions, you would list that there. Okay, so that's one of my continuous integration setups via Azure Pipelines. The other CI system I use is Precommit CI, which I wrote. And there's no special configuration that you need for Precommit CI. You basically just reuse the precommit config that you already have, so I didn't need to do any special setup for that. It's just reusing the same tools that I would use locally. Okay, next is changelog. Not all my repositories have a changelog. I find that at least for the simpler and smaller tools, that a changelog doesn't really add much information on top of what your Git history would do. So sometimes I leave it out, but sometimes I include it. So this will have, change history. And one recommendation, if you're going to write a changelog, just tiny thing, add the date. Makes it a lot easier to figure out when releases happened. But yeah, this is my changelog. And I manually write out this changelog. There are some tools that make this easier to work with. Like we work with Town Crier in PyTest, which allows you to use changelog fragments and then aggregate them at the end. It works sometimes, like it can be useful. But I find that a lot of the automatic changelog tools lose some of the nuance when you're combining a changelog at the end. And I often find that if I was using an automatic tool, I would then go over every changelog and reword it slightly when I'm making a release to have the language be the same. And at that point, if I'm going to reword every changelog entry, I might as well just write the whole thing myself. The next thing that we have is a license. And for my open source libraries, I tend to include a license that is permissive. I like MIT personally. It allows people to have a lot of freedom for using your software. But to each their own. I am not going to argue about licenses, so please do not comment about them. You'll notice here that I have just the original copyright date. I don't update this. Don't send me a pull request to update this. There's some legal precedence that says that there's no reason to continue to update this year after year, and so I tend to just use the initial year that I contributed to library. Initial year for copyright. Okay, so that's the license. Let me get rid of some of the junk again. fxfd. We don't need that mypack hash anymore. Okay, we already talked about this file. I usually have a readme, and that'll just tell the people about the project. readme.md talks about the project. I include a requirements dev. This actually isn't super necessary, and we'll get to that in a second when we look at the talks.ini. But my requirements dev is just going to list the libraries that I need at test time. In this case, I'm using cov defaults. That's a tool that I wrote. I guess we can talk about this here. Requirements dev.text. This is testing dependencies. Dependencies. You can also list these in talks.ini instead of having a separate file. This is mostly left over from when I used to not use talks and use MIG files. But I still find it somewhat convenient because sometimes you want to do pip install -r. Anyway, if we look at the libraries here, we have cov defaults. This is a coverage plugin that I wrote to set reasonable defaults for coverage. Coverage is a code coverage tool. Coverage. And basically, it helps you know whether your code is actually tested or not. And then finally, PyTest, which is a testing tool. This is the test runner, discovery, assertion framework, etc. I also maintain PyTest. It's another tool that I work with here. All right, let's go to our setup metadata next. First, we'll talk about setup.py. This file is fairly barren because I have moved all of the metadata to setup.cfg. So I have this very simple setup that doesn't pass any parameters along. Of course, when I used to just use setup.py, you would have your name, version, etc., and all the metadata in code. But having the metadata in code makes it really difficult to modify it, format it, etc. Like this tool wouldn't even work because modifying Python code is pretty tricky. But anyway, setup.py is usually very minimal. Occasionally, I need to do some things that are not supported by setup.cfg, so you might sometimes see some code in here. Like one example is this library, for example. This has a C extension, in fact, a CFFI extension, so I need to have a little bit of extra customization here. This is to trigger CFFI. This is to add ABI3 wheels. This is also part of the ABI3 wheel stuff. So occasionally I will have a little bit more stuff in here. Sometimes more things for non-metadata uses. And so like this is a C extension, so it needs special stuff there. Then we'll go to setup.cfg. Setup.cfg is my declarative metadata. And most of this is auto-formatted. Most of this I don't actually set manually. A few of the things that are set manually are these three fields here, the URL, of course my name, but all of these classifiers, they get generated automatically by setup.cfg format. So I don't even have to think about them. They just basically get updated based on my Python requires setup here. You notice I also have my install dependencies here. So for instance, this library depends on Rumel YAML as well as TOML, and it does that for its checkers. But if you have any, library dependencies, I would specify them here. And this is a multi-file library, so it is going to use package finding to discover its top level. And the way you do that is with this packages equals find and with this options.packages.find. You'll notice when we go to the single file distribution that we won't see either of these things here. So we're using packages find to discover the top level packages. And if you had a source layout, this would be a little bit different. I believe there's a top level option to find. I personally don't use a source layout. I have talked about how you would set up a source layout and why you might want to use that, so I will try to remember to link that in the description. But I personally don't use a source layout. And most of my reason for not using a source layout is it's a little bit fiddly. And I have standardized my setup metadata enough that I don't make the mistakes that it prevents, and so I don't find it that useful. But anyway, yeah, I don't use a source layout personally. All right, my setup.cfg also contains a little bit of metadata for, here's some of the entry points of that tool. It also contains some of the entry points for other libraries that I'm using. So for instance, I've put my coverage metadata in here as well as my MyPy metadata. And of course, this could go in whatever configuration file that you would want to use. Like I could have split this out to mypy.ini and coverage.ini or project.toml if you really wanted to, but I put it here. Seems to work fine. All right, I think all that's left now is to talk about, I guess, we have to talk about tox.ini, yeah. So Tox is another developer tool that I use and another one that I maintain. And Tox is a way to run tests and provision virtual environments and kind of do command automation. You can kind of think about it like as a makefile-like tool, except it knows things about Python virtual environments and environment variables and some other fancy stuff there, and can do package installation and that sort of stuff. So it's a little bit fancier. It's kind of like a fancy make for Python. And in here, I've configured 2 environments. This one is actually a little bit special. Usually I don't do this, but this particular one I have for whatever reason. But this is my test environment. This usually just runs coverage to run my tests, which runs PyTest to run my tests. And I also add this mostly for other contributors. I actually don't use this Tox environment myself, but if people want to be able to run pre-commit easily, and I don't expect them to have it set up globally, they can do that as well. You'll notice I also have this pep8 config here. This is for auto pep8, which reads it from here. That's why I put that there as well. But yeah, this is how I run my tests and the environment setup here. The last thing about my multi-file library is really my directory structure. This pre-commit hooks, this underscore here, this is where my multiple files that are being packaged into this library live. So it is a directory with an init.py, and it has a whole bunch of other things. I usually find when I'm making a multi-file library that, I usually try and make a single file library, and if the single file library gets too big to fit in one file, then I'll split it into a multi-file library. Mostly because this is potentially more to keep track of, and if you're in a single file, it's easier to see where all the code is. Say like project name slash, and this is kind of the top level of the distributed code. And you'll see a whole bunch of stuff here. Note that my init.py is empty. I don't put code in here. I find it really hard to search for. I also find it really easy to accidentally introduce import cycles and a whole class of other problems that I just don't want to deal with, so I don't write code here. So this is always an empty file in my project. There might be one or two where there's like 2 or 3 lines, but I just don't put code in my init. That's my notes. Init.py. I don't write any code here. The next directories we have is tests and testing. And I specifically picked this project because it has both of these directories. The test directory is usually where I put my tests. And so you'll see all of my tests are in here. And the testing directory is where I put code that's helpful for tests, but is not actually test code itself. Where my tests go. Testing, this is code that's helpful for tests, but it's not tests. And the reason that I have this special directory is I don't want to distribute the code that's inside this testing directory as part of my library. Like, no one needs my little test helpers, but they are useful to my tests, and it gives me another place to separate out kind of glue code for my tests. Another thing about my tests is my naming convention. I like to do _test.py at the end rather than having it at the beginning. And the reason for that is so that I can tab complete my tests. Because if they all started with test, I would do, my editor test/test and then tab a bunch of times. Well, this matches for a different reason, but you can imagine if they were all named in the opposite way, I would have a harder time tab completing them. So I like to put it at the end. And I use a tool that's part of Predicament hooks to enforce that. That comes from this name tests here. So I name them _test.py for tab completion. Okay, I think that's most of what I wanted to cover for my multi-file library. And so next we'll move on to a single file library. And it's going to be basically all the same as this, except we're just going to talk about the differences rather than rehashing all of that. Okay, so next is our single file library. And for that, we're going to be talking about AST Pretty. This is just a very simple AST Pretty printer that I wrote. And you'll notice here that we don't have a top-level directory for our package. We just have a single Python file. And the main difference here is that we're using PyModules instead of packages. PyModules, and this is in setup.cfg. We are using PyModules instead of packages. And I just find this simpler, and so that's why I tend to prefer single file libraries. Now, unfortunately, one unfortunate side effect of single file libraries is there is no way to do a py.typed file. There's not really a good way to indicate that this has type annotations that a third party could consume. I'm hoping that sometime in the future there's a way to work around that, but for now, just say shrug, whatever. It's not super important to me to support that at the moment. But yeah, another reason that I might want to move to a multi-file library is if I wanted to satisfy. If I don't, then I don't. And that's the main difference between the two here. So it's really just this PyModules here. I don't really have to change much else there. And the entire library is just in this one single file here. And this one's only 200 lines, so it's not really worth splitting up yet. But maybe if it grew to 1,000 or 2,000, I would split it up. Or 3,000 or 4,000, which is where I've split up other libraries, because it can get a little bit unwieldy. You also notice here I don't have a testing directory. I just didn't have any special testing specific code, and so I just didn't include it. So this is kind of an optional part of my setup here. All right, and the last thing that I want to talk about is things that are not libraries, but instead are applications. And applications I structure a little bit differently. And we're going to use, this is part of pre-commit CI itself, but is not going to go into the code, so I'm just going to show you the structure of it. And it's largely set up the same as the other ones. You'll notice here that there's this special activate.sh and deactivate.sh. And those come from a tool called activator with 2 A's. Yes, it's intentional. And I talked about this in another video, so I will link that in the description as well. And this is an auto virtualenv activator. And it uses these two files, .activate.sh and .deactivate. Deactivate.sh. You'll notice that activate.sh is a dead symlink to vmfpin activate. And if I run my virtualenv setup here, it should automatically activate my virtualenv. It's going to install a bunch of packages here. You'll notice it's not activated up there. And after this runs, well, first activator will prompt whether this is okay. And usually when it prompts, I will double check these two files to make sure that I'm not owning myself here. Deactivate just contains the string deactivate, and this comes from virtualenv, so I trust the contents here. So I will say yes, and now it will automatically activate this. And if I cd out and cd back in, you'll see that it now remembered my decision before and automatically activates my virtual environment. So that's kind of a cool tool. You'll notice here that I don't have a setup.py. I do have a setup.cfg. So an application, there's no reason for a setup.py because I'm not distributing a library. In fact, I'm not distributing this at all. It's really just being deployed somewhere. So no setup.py. And my setup.cfg doesn't contain any metadata. It's just containing my py settings and I guess coverage settings in here as well. You can see that I need to improve my coverage a little bit. This particular app doesn't have perfect coverage. And let's see, setup.cfg does not contain metadata. And then the next thing you'll notice that's different is we have 4 requirements files here. And this actually comes from a convention from a tool that I wrote called requirements tools. And this was before I knew about pip tools, or this was before poetry existed, or pipenv, or any of those sorts of tools. And requirements tools is a tool for helping you freeze all of your requirements. This is not my fault. I don't work here anymore. But it has basically 3 scripts, one being a validator for making sure your requirements are fine. So we do check requirements here. It runs a few tests and actually uses PyTest to do that. There we go. 2 V's. So it validates some sanity checks about my requirements files, and it includes this upgrade requirements tool, which is basically just installed from the 2 minimal files. So requirements minimal is kind of the top level things that my library needs to function. So it needs Boto3, it needs cryptography, and it needs JWT, but the crypto variant of JWT, so that I can use the actual cryptography stuff. I also have a requirements dev minimal. This lists the development dependencies that I depend on. So here I'm using coverage, code defaults, I'm using coverage, I'm also using packaging for some validation stuff, and I'm using PyTest as my testing library. And what this upgrade requirements tool will do is it'll take those 2 input files and it'll regenerate the output requirements.txt and requirements.dev.txt with the most recent versions. You can also twiddle them manually if you want to, or adjust your input files such that those get pinned. And the reason that I pin these dependencies is for reproducibility, to make sure that, you know, if I take this this application and I try and build it at a later date, it's going to use the same package versions as when I built it earlier. And yeah, you'll see here that it updated all these versions for me. So if I wanted to bump those, I could. But we're actually going to discard that for now. Okay, so we use requirements tools to manage requirements, and this is similar to pip tools, pipenv, poetry, etc. And it uses requirements minimal and requirements dev minimal to be input requirements. Input requirements and requirements.txt and requirements.dev.txt to be pinned versions. So I install from these 2, and these are just metadata for my repository. And yeah, and that's what those files are. And then beyond that, it's very similar to, actually, let's clean up everything again, back to dead things. So it's very similar to the other repositories at this point. So like I still use pre-commit with all of those tools that I talked about before, except for the setup CFG formatter, of course. we have our requirements files, we have our tool configuration. This is specific to the app. You can ignore that file. We also have a git ignore. This one also uses GitHub Actions because I did want to pay for Azure pipelines, and the app doesn't need multiple configurations, so it was very easy to just set up GitHub Actions through that. So you'll see we have a few files in here. This one runs the test, and this does the actual application deployment. And then we have, tests and testing, very similar to the other ones. But that's kind of how I set all these sorts of things up. I will, let's just scroll through this one more time. So multi-file library, this is where most of the tools get involved. So if you want to screenshot that or press pause or whatever. And then we have, our single file library where the main difference is Pi modules, and then applications, the main difference being that there's no setup tools metadata. And I pin all the versions to make sure that it's reproducible. Note that I don't pin things in libraries, and that's because I want to know when things break. I want to know when I have an incompatibility with the latest versions of any of my dependencies. And so I leave those unpinned or greater than or equal to if I want to. Anyway, this was an extremely long video where I went over a whole bunch of tools, and if you're still here, I don't know what you're doing. Anyway, hopefully you found this useful. And if you have additional things you would like me to explain, or any of the tools that I went over that you want me to talk about in more detail, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.